We're going to be continuing our sine and cosine, our T3 outcome, by looking at the cosine law. We've talked about the sine law before. We've talked about how it can create the ambiguous case. However, not all triangles can be solved using the sine law, right? When we don't have a pair, we can't use the sine law. That's where the cosine law comes in. It allows us to find unknown angles and sides in any type of triangle. We can do this with right angle triangles, or we can do it with oblique triangles. There's two situations where this is going to come in handy, where the sine law will not work. So if I have a side angle side triangle, so where I know the sides opposite a known, or I want to find the side opposite a known angle, and I know the two sides. So I know a side, right? I know the angle between that and the other side I know, right? Here, I have no pairs. I can't use sine law. I don't know side C, I don't know angle A, I don't know angle B. I have no pairs. So the cosine law is going to come in handy for a side angle side triangle. Right? Different than a side angle triangle. It tells us the order we have the information in. Or we can also see a side triangle where I know all three side lengths. So again, I have no pairs because I don't have any angles, but I still have three pieces of information for this triangle. So for any triangle ABC, and again, we can adjust these variables depending on the triangle we're working with, but we have this formula. It starts out kind of like Pythagoras. A squared equals b squared plus c squared minus 2 times b times c times cosine of A. So noticing a few things. The angle is related to the side length we're trying to find. And then the b's and c's show up in the middle. We can also rearrange this, and you'll see this on your formula sheet as well. If I get cosine A by itself, so if I have something equal to cosine A, it's going to look like b squared plus c squared, so they can stay where they are. I would then have to get cosine A by itself, divide by 2bc, and the a squared would move to the other side as subtraction. So you have access to both of these formulas on your formula sheet. It's the same formula. The question really is, or the point of each of these is, the first one, if we want to find a side length, right? Because that a squared, that lowercase length value, is mostly isolated. And then the second variation is when we want to find an angle, right? So the question is, what are you looking for? Are you trying to solve for a side length? Then use the version on the top where a side length is mostly isolated. If you're trying to find an angle, so like in a side triangle, we want to use the version on the bottom where an angle is mostly isolated, right? A, B, and C are completely interchangeable. So if I instead was looking at this triangle and I wanted to find angle C, so because I'm trying to find an angle, I would use the bottom formula there. But I need to find angle C, so if I call this cosine C, it's going to make changes to the rest of the equation as well. B squared plus A squared, right? These first two numbers are the two sides that aren't related. The side that's subtracted is related to the angle, right? Before it was A squared, solving for angle A. If I'm solving for angle C, I'm going to make sure that I'm subtracting C squared. Then on the bottom of the fraction, I had 2 times B times C. Those were the terms I was adding. Now it's going to be 2 times B times A. Right, so looking at those parallels, these two have to match the two on the bottom. Or if we're looking in the first formula, the two that are added are the two that we're multiplying. And then the last one has to match the angle we're working with. Right, so we can rename this anything we want, just make sure that you're putting the correct variables in the correct spots. So let's look at a triangle and see how this can affect us. We have a triangle here. This is a side angle side triangle. Right? I have angle S, but I don't know side S. That's what I'm trying to find. Lowercase s. I have side t, but I don't know angle t. I have side r, but I don't know angle r. I have no pairs. Let me write that here. No pairs. So we'll try cosine law. If I have pairs, I'm welcome to use sine law. So let's start. I'm looking for a side length, so I'm going to use the formula a squared equals b squared plus c squared minus 2bc cosine a, right? Because this is the version of the formula that has an side length mostly isolated. That lowercase a, that a squared at the front, that's what I'm trying to find. Now, I'm actually trying to find s. So if I rename that first variable s, b and c become r and t, again in no particular order, minus 2. It was another b and c here before, so it's going to become another r and t. And then the angle was related to the side I was finding, so we're going to talk about cosine of s. So, plugging in all the things I know, I should know everything on the right side of this equation. Right? I don't know side length s, but I know side r is 103, side t is 73, minus, and this is like one big entity. I'm subtracting whatever the product of 2 and r and t and cosine s is. Oops, let me write that. That's more of a multiplication. So 2 times 103 times 73 times cosine of 66. So I can plug that into a calculator. So I'm going to do 103 squared plus 73 squared minus, and at this point I might recommend brackets just so you're extra sure that all of those terms are being multiplied together. It's not necessary here, but we will see where it comes in handy later. So 2 times 103 times 73 times cosine of 66. And you make sure you're in degree mode, right, in your calculator. Under mode, you should have degree highlighted in that fourth row. And if I hit enter, this is my s squared. So back in my notes, s squared is equal to, and this big whole side was equal to 9821.5-ish, right? We've kept all the decimals in our calculator, but that doesn't really make sense in the question, right? If one side is 73, another side is 103, if our third side is like almost 10 times as large, that's probably not quite right. And that's because we still need to find s. This is s squared. So I square root both sides. In my calculator, I square root my answer, and I get 97.8. And the units are millimeters from the question. Right, so there's our unknown side using cosine law. So let's try another one. We're looking for our unknown side B. I know side A, I know side C, I know angle B. I have no pairs, so I have to start with cosine law. So again, solving for a side length, we're going to use that second formula. Specifically solving for side B, so I'm going to have b squared. My other two sides are a squared and c squared. So that means I'm going to subtract 2 times a times c, right? The squares have to match the products, times the cosine of angle b, right? The angle has to match the side length we're looking for. And again, we want to make sure we're including all the information we have. We only have angle b, so it has to show up in there somewhere. So plugging in what we know, I don't know b squared, but I know everything else. 75 squared plus 30 squared minus 2 times 75 times 30 times cosine of 115. So I plug that whole big thing into my calculator. I do 75 squared plus 30 squared minus, and again, your calculator will do this right. If you don't include the brackets here, it's not the end of the world because it knows to do multiplication before any subtraction. So it knows to do I lost something here. It knows to do 2 times 75 times 30. Oops. Times the cosine 115 before it's subtracting that from anywhere. There we go. So 8,426.78. But again, that's b squared. I still need to square root. If I'm talking about length b, I need to isolate b completely. And so that third side length, that length b, again, noticing here it should be our longest side because it's across from an obtuse angle. I square root my answer, and I get 91.8. I'm just going to quickly fix an error I made above. This one should be 99.1 millimeters. I had just typed something incorrectly into my calculator. So let's try another triangle. This is a side, side, side triangle. So I know all of the sides, I know none of the angles. And we want to solve the triangle, which means I need to find every unknown here. Let's label them. Let's call this one A. It doesn't matter, but let's call this one A, this one B, and this one C. I need to find all three of those. I know side A, side B, and side C. So starting off side, 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 the only thing I can do is cosine law. So let's find something. Let's find angle A first. It doesn't matter. We could find any angle first. Because I'm solving for an angle, I want to set this up as cosine A. And then it was b squared plus c squared minus a squared over 2bc. Right, it's the same formula as we just used before. It's just been rearranged so that the angle is on the left side of the equal sign so we can solve easier for the angle. I plug in all my values. 76 squared plus 54 squared minus 112 squared, right? You should always be subtracting the side related to the angle you're trying to find. And then the first two, the positive terms, are the only ones that should show up in the denominator. Now here we need to be extra careful. So in my calculator, I'm going to do 112 squared. And what I'm actually going to do is I'm going to put, let me clear this. There we go. So I'm going to put my whole numerator in brackets. 112 squared plus 54 squared minus 76 squared, So what I'm going to do is I'm going to put my whole numerator in brackets. I'm going to do 76 squared plus 54 squared minus 112 squared. Right, that's my whole numerator. That was everything I had on top. Then I'm going to hit divide, and I'm going to start another set of brackets for my denominator. And I'm going to do 2 times 76 times 54. And this is super important because if you don't include these brackets on the bottom here, your calculator is going to calculate all this. It's going to divide by 2. It's going to cut it in half. And then it's going to take that answer and start multiplying because it is trying to follow order of operations as best it can. So make sure you include brackets around your denominator. You can also, if you have a newer calculator, you can hit alpha F1, you can make a fraction. But if you have an older calculator, if you don't have this option, brackets are totally fine. Right? I would recommend brackets always around a numerator and a denominator in any part of math. So that's my value for cosine A, right? That was just the right side of the equation. So cosine A is equal to negative 0.426. If I want to find A, I do the inverse cosine of both sides. So my A value second cosine, my answer gives me 118 degrees. So 117.98. 118 degrees. That's my angle A. Let's find another angle here. Let's find angle B. I have a choice now. I can solve using cosine law. Again, I have some sides. However, now I have a pair. I know angle A and I know side A. So I could use sine law in this moment if I wanted. And let's try that just for practice. Sine A over A because I know angle A and side A. And I'm going to set it equal to sine B over B because I'm trying to find angle B, but I know side length B. So plugging in the numbers we have, sine 118 over 112 equals sine B, right? B is my unknown, over 76. We want to be careful with using sine law because we still could create that ambiguous case. Even though we know, right, from using cosine law, there's only one option for angle A, right? If we had found a different angle first, sine law could cause us some problems. So be careful using sine law. Always check for that ambiguous case. Since we're starting with an oblique angle, 108, or an obtuse angle, 118, we don't have to worry about the ambiguous case here. So we isolate capital B, right? We're solving for the angle. Multiply 76 to both sides. We'll take the inverse sine of this result, right? Because that's telling us sine B is 76 sine 118 over 112. And so angle B, right, we take the inverse sine of both sides to isolate B completely. I'm taking the inverse sine of 76 times sine 118, 118 divided by 112. And I get 36.8. So 37 degrees says to the nearest degree. Again, note, if we had started with an acute angle, we're using sine law, we still have to be wary of that ambiguous case. Cosine law does not cause the ambiguous case. So I'd recommend, when possible, use the cosine formula, but sine can be a little easier, a little quicker to work through. So you have that option as well, as long as you're cautious with your answers. So angle B is 37 degrees. Angle C, we could do cosine law, we could do sine law, or we know that I have three angles here. They have to total up to 180. So if I subtract the two angles I already know, I'll find out that angle C is 25 degrees. And we've solved the triangle, right? We know every side length, we know every angle inside. So cosine law, make sure you have both of those formulas in mind, right? You have access to them, and make sure you know when you have to start with sine law and when you have to start with cosine law. You're questioning yourself every time, do I have a pair already? Do I know an angle and its related side length, right? Do I have both A's, both B's, both C's? Do I have at least one pair? Then I can use sine law. If not, you need to start with cosine law. So in a situation like this, we can deal with some word problems. A surveyor stands at a point north of a pond. So, right, make sure you have that prior knowledge, northeast, southwest. So here's our surveyor at the north end of some pond here. From this point to the east side of the pond is 436.7 meters. And then from that point to the west side of the pond, so here's our east side, here's our west side. It's a little further, it's 703.2 meters. And it's asking us, what is the width of the pond, essentially, right? The angle between the measured sides is 73 degrees. What is the distance across the pond? Right, and this is how surveyors can actually determine how large things are, right? You're not going to walk through the whole pond with a measuring tape from one side to the other, but you can walk across the land, measure those points on either end, and use these tools. So I'm looking for side length N. I know side W. I know side E. I have no pairs. I need to start with cosine law. Because I'm looking for a side length, again, I'm going to start with the one that looks like a squared is b squared plus c squared minus 2bc cosine a. Right? I don't want to use the one we just used in the last one. Otherwise, I'm going to have to do a lot of rearranging to isolate a side length. So I might as well make my life easy so that n squared, right, now I'm replacing the letters I'm using in the question. N squared is e squared plus w squared minus 2ew cosine of angle n. Right, because these are the values we have. These are the variables we're using. I'm trying to find lowercase n. I'm trying to find the side length. I know 703.2 squared and 436.7 squared minus 2 times 703.2 times 436.7 times cosine of 73. And again, I can plug that all into my calculator in one big go. 703.2 squared. 703.2 squared plus 436.7 squared minus, and again, I'd recommend some brackets here just for that good practice. 2 times 703.2 times 436.7 times, right, all of these four things are being multiplied together before we're doing that subtraction. Cosine of 73. So it gives me a very large number, but that's okay. That's my n squared. 505,629.77 dot dot dot. My actual length n comes from square rooting that value. N equals, I go back to my calculator, I square root that whole big long answer, and I get 711.1. My units are meters based from the question. Right, and because it was a word question, I'm going to give a word answer. The pond is 711.1 meters across. Right, and without somebody having to jump in a boat or wade through the water all the way from one side to the other, we can find out how wide this pond is. So that's the cosine law. It pairs really well with the sine law. Reminder that your outcome check is on Thursday in your classes, right? If you've been away, make sure you're still prepared. You're reviewing this video, you're reviewing the posted notes. If you have any questions, contact your teacher.